Welcome to Leetcode JavaScript, a channel where we solve every single Leetcode question using JavaScript. Today we have 374, guess number, higher or lower. This is an easy question. We're playing the guess name game. The game is as follows. I pick a number between 1 and n. You have to guess which number I picked. Every time you guess wrong, I will tell you whether the number I picked is higher or lower than your guess. You can call that the predefined API guess, which returns three possible results. -1 if guess is higher than the number I picked, 1 if it is lower, or 0 if it is equal. And you gotta return the number that I picked. Now, this question is actually quite easy. Let's think about how to solve it. So the brute force approach would be just spit out every single number between 1 and n. You're eventually gonna get it, and that has a time complexity of O of n. But we can actually do better. We can do better than linear. And this is actually quite similar to the question that was yesterday. That was a bit harder. But this is some sort of modified binary search. This is conceptually a binary search. And let me show you more or less how it would work. Let's say we have a number between 1 and 10. And we could guess 1, 2, 3, 4. Eventually, we're gonna get the number. But a faster way to do so is let's get the number in the middle. In this case, it's going to be 5. And let's say we know it's lower. And in that case, it's going to be between 1 and 4. And we just pick the number in the middle. In this case, let's say 2. And just again, let's say it's going to be higher. And then we know for sure it's going to be 3. And that's going to take a way shorter amount of time than if we just guess every single number. So this is relatively simple. This is going to be a version of binary search, and this is actually going to be running in logarithmic time. So the time complexity here is going to be O of log of n. Okay, so let's start implementing this, and we're going to have a low, and we're going to initialize at 0, and let's initialize as high as n. And then we do while low is less than or equal to high. And if you ever done binary search, this looks extremely familiar because this is exactly what we do in a binary search algorithm. It's just that we're not really using an array to search, but rather we're doing it using this API that's been implemented for us. Now we're gonna have mid, and mid is gonna be math, that's floor. It's going to be low plus high divided by 2. And meta floor is just a function to give us the integer part. Say we have 0 and 9, and we're going to guess a number between 0 and 9. And we start with the middle, it's going to be 4.5. But we don't actually want a decimal number, we want a whole number. So meta floor is going to just be at 4 instead of 4.5. Alright. So now we gotta check all the three cases that we're given, and that's relatively simple. We do if you guess high, so that's equals 0. Then we're gonna return high. We also gotta check if mid, if guess mid is equal to 0. Then we're going to return mid. Now we're also going to check whether guess mid is equal to -1, meaning that it is higher than the number that we're given. In that case, we're going to set high to be equal to mid, and then we keep starting the loop again, and then finally we're going to check whether guess mid is equal to +1, and in that case it means it's gonna be lower, and in that case low is equal to mid. Now let's try running this code, and it is accepted. Let's run this code, right, submit it, and it is accepted. This is an extremely fast algorithm. It's faster than 99% of JavaScript online submissions. And again, this is a simplified or modified version of binary search, where the time complexity is going to be O of log of n, and the space complexity is going to be O of 1 because we're not really using any additional space. Now, thank you so much for watching. Don't forget to like and subscribe.